Okay, this video is all about the Big Bang and the steady state theory. So today we're going to be looking at the question, how did our universe begin? Which feels like a little much for a Monday morning, but here we go. Firstly, we need to think about what evidence we have to give us some clues as to the origins of our universe. And in our previous video, we looked at one piece of this evidence, this phenomena called redshift. Redshift is the idea that light from distant galaxies gets shifted towards the red end of the spectrum. In other words, its waves get stretched. We then related this to the Doppler effect and concluded that this shift meant that those galaxies were moving away from us. And we found the further the galaxy was away, the larger the shift, the faster it was moving away from us. And hence the universe is expanding. If you'd like to run through that in more detail, do check out the video about redshift. So, okay, now we know that the universe is expanding, we're going to look at two theories that support that evidence. And these two theories are called the steady state and the Big Bang. Let's start with the steady state theory. This theory states that the universe has always existed, it always will, it's always looked this way, and it looks the same in every direction. But since we know that the universe is expanding, thanks to our observations of redshift, we know that all the stuff in the universe is moving away from each other. But the universe in this theory has to look the same at all points in time. So that means when this stuff moves away from each other, there's constantly new matter being created to ensure that the universe remains roughly the same density and looking exactly the same as it always has done. So this theory of the universe implies that the universe has no beginning and no end. Good job, the universe is in a book. Okay, so that was one theory of the origins of our universe. Now it's time to look at our second theory, Big Bang. Now, the Big Bang states that in the beginning, there was nothing. The idea is that basically all of the stuff that we have in the universe was crammed together so that it occupies an incredibly small, infinitesimally small, and incredibly dense point. Well, it would be dense, I guess, if I tried to stuff everything in the universe into an infinitely small place. And then, from this small space, the universe exploded. Hence, the Big Bang. I always think it's quite a cute name, really. And since this explosion, the universe began to expand. And the idea is that it's been expanding ever since. Since we can look at where our universe is right now and trace that expansion back to a moment in time, predicts that the universe is roughly 13.8 billion years old using this theory. So, which one of these two theories is correct? Well, both of them support the idea that the universe is expanding, and therefore our redshift is evidence for both of these two theories. So we need further evidence to decide which one of these two theories will come out on top, entering some radiation in the form of microwaves. Everywhere we look in our universe, we will find some microwave radiation. And it is called cosmic because it's in space, microwave because that's the wavelength of this radiation, background because it's everywhere at all times, and radiation because it's radiation. Cosmic microwave background radiation, or CMBR for short. Yep, we have literally given radiation its own nickname. And this evidence of this radiation only makes sense in the Big Bang theory. This is because this radiation is predicted from an initial explosion, and as the universe has cooled and expanded over time, this radiation has been stretched out into the microwave region of our EM spectrum. So there you go. Cosmic microwave background radiation was the nail in the coffin for our steady state theory, and the Big Bang theory is a theory accepted by physicists today. Okay, hope you found that helpful. Please make sure you download the notes. If you like the video, give us a like and subscribe. Thanks for watching.